Welcome to Module 1 of Pharmaceutical and Medicinal Chemistry. Chapter 1.3 in this module is about metabolites and antimetabolites. The instructor for this chapter is Dr. P. Bhushanavati, Controller of Examinations and Selection Grade Lecturer in Chemistry, St. Joseph's College for Women Autonomous. Learning outcomes. By the end of this chapter, learners would be able to identify and classify the compounds in living systems as metabolites and antimetabolites, recognize their importance, distinguish between them, comprehend some important functions, and figure out the risk in applying antimetabolites for the treatment of cancer. Contents. Introduction to metabolites, classification, functions and applications, antimetabolites, applications of antimetabolites, and a word of caution on antimetabolite uses. Metabolites are small organic molecules that are involved in various biochemical processes within living systems. They are the intermediates, products, and substrates of metabolic reactions. They play a crucial role in energy production, growth, and reproduction. Examples for metabolites are antibiotics and pigments. Classification of metabolites. Metabolites are classified into primary and secondary metabolites based on their function. Primary metabolites are organic compounds that are directly involved in growth, development, and reproduction. They are carbohydrates, lipids, amino acids, nucleic acids, etc. Secondary metabolites are molecules that are not directly involved in the core metabolic processes. They play specialized roles in interaction with the environment and defense. Secondary metabolites are produced in response to specific stimulus such as an environment condition or a stressor. Primary metabolites are essential for basic life processes and they are found in all living organisms. Secondary metabolites are often uniquely found in specific taxonomic groups and they play secondary biological functions such as imparting color, fragrance, defense, etc. Their useful applications are in dyes, medicines, and drugs. Functions of several secondary metabolites are unknown even today. Examples for secondary metabolites are alkaloids, flavonoids, and terpenoids. Functions of metabolites. Energy metabolites play an important function in energy production. Examples are ATP and NADH, which are involved in the electron carrying reactions and energy producing pathways. Building block metabolites are involved in building up of macromolecules such as proteins, nucleosides, and nucleotides. Signaling metabolites like CAMP and CGMP are involved in intracellular signaling pathways. Metabolites which are produced as waste products are carbon dioxide and urea. Secondary metabolites also play important roles in defense, communication, and interaction with the environment. Applications of metabolites in medicine include disease diagnosis as biomarkers for drug monitoring, drug development, personalized medicine, monitoring treatment progress, nutritional assessment, toxicology, and understanding disease mechanisms. Antimetabolites are a class of drugs that interfere with the normal metabolic processes of cells, particularly those involved in DNA and RNA synthesis. These drugs are designed to mimic the structure of natural metabolites and however once incorporated antimetabolites hinder or block essential cellular processes leading to the suppression of cell growth, division and proliferation. The primary use of antimetabolites is in medicine to treat various conditions, particularly cancer. Applications of antimetabolites in medicine. Antimetabolites basically they mimic a necessary metabolite, but they do not play the role of the metabolite. Instead, they suppress the pathway by acting as an analog. Examples include folate analogs, pyrimidine analogs, purine analogs, nucleotide analogs, and antiviral nucleotide analogs. Anti-metabolite uses. A word of caution. If antimetabolites can be highly effective in targeting rapidly dividing cells like cancerous cells, they can also affect healthy cells. They can lead to side effects like bone marrow suppression, gastrointestinal disturbances, and other systemic issues. Medical professionals carefully consider the balance between the potential benefits of treating cancer and the possible side effects when using antimetabolites or any other cancer treatments. The choice of treatment depends on the specific type of cancer, its stage, the patient's overall health, and other individual factors. In a nutshell, in this chapter, we have learned that metabolites play a crucial role in biochemical pathways and they find extensive application in the field of medicine. Primary metabolites like carbohydrates, proteins, lipids, and nucleic acids mediate core metabolic processes like growth and reproduction. Secondary metabolites like pigments, flavors, etc., are needed for defense and communication. Antimetabolites are a category of drugs which interfere with normal metabolic pathways by mimicking the natural metabolites. Medical professionals consider the balance between the benefits and the possible side effects when using antimetabolites for cancer treatment. Thank you.